Section 2.5 is dealing with zeros of polynomial functions. We already know that zeros is where it crosses the x-intercept, or the x-axis. That's where we have our x-intercepts. We have zeros. Those are also called solutions. Okay, there's a bunch of different names for them. But we're just going to look at some different things. Really, your only new thing here is the rational zero test. There's a star. And we'll talk about that in just a sec. First, just notice for me, if we have a polynomial where it's x to the n could be anything, but it is the highest power, so just notice that this is the biggest degree, just like when we were looking at 2.1 when we were dealing with our leading coefficient. Then f of x has n zeros. So whatever your highest power is how many zeros you should have when all the multiplicities add up in the end. Okay, with this rational zero test, this is just a way to find the possible rational zeros. Okay, if you're given p, or p is the factors of the constant term, so your constant term is always the one without the variable with it. So up here it would be c. Q is the factors of the leading coefficient. Factors is just like if it's 4, then it's 1 and 4, because 1 times 4 is 4, or 2 times 2 is 4. So our factors would be 1, 2, and 4. We're going to look at some examples of this, but just really notice that these are only possibilities. Most of the time, most of them will not actually be our real zeros. Sometimes none of them will be our real zeros. But it's just a fast way of making a first guess at these type of things, which is just what our zeros could be. Okay, for an example like this, where all it's asking to do is list the possible rational zeros, right? It's just the things that we could have. So don't forget this is p over q, where p is the factors of the constant term, q is the factors of the leading coefficient, which is just a 1 in this case. X cubed is my highest power, so I know I'll have 3 zeros when I work this thing out. But all I'm really trying to do is just list the possible rational zeros. So my constant term is 16. My leading coefficient is 1. So the factors of 16, if I list them out, are like 1 and 16, 2 and 8, or 4 and 4. Those are the only factors of 16. So on top, when I put the factors of this, I'm going to have 1, 2, 4, 8, and 16. Something else we have to consider is that negative 1 times negative 16 is also a positive 16. So these could all be plus or minus what the number is. So really there are lots of possible rational zeros. Most instances will have a ton of them. Okay, and this is all over the factors of the leading coefficient, which is 1. Well, the only thing that multiplies to be 1 is 1 and 1, so I just have plus or minus 1. Now what we have to do is actually divide everything on top by the numbers on bottom. In this case it works out pretty nicely because there's only one number on bottom. So our possible rational zeros are only plus or minus 1. 2 divided by 1 is 1, so plus or minus 2. 4 divided by 1, so plus or minus 4, plus or minus 8, or plus or minus 16. Those are all your possible rational zeros that you could have for this polynomial. Just another example where I have to list out the possible rational zeros. So all this is the p over q again. So my factors of my constant term, which is negative 2, over the factors of the first term, or my leading coefficient. So I can have the factors of 2 are just 2 and 1, so plus or minus 1 and plus or minus 2 all over. Factors of 4 are 1 and 4 and 2 times 2, so 1 plus or minus 1 plus or minus 2 or plus or minus 4. Okay, now with this I have multiple things on bottom, so you're going to have to take each term on top and divide it by the number on bottom, one at a time. So 1 divided by 1 is 1, so I have plus or minus 1. 2 divided by 1 is 2. Now I move on to the next thing. 1 divided by 2 is plus or minus 1/2. 2 divided by 2 is 1. I already have it, so I don't really have to write it again. 1 divided by 4 is plus or minus 1/4. And 2 divided by 4 reduces to 1/2, which I already have as well, so again I don't have to write it again. So these are the only possible rational zeros for this instance. Okay, here's a different problem altogether, a little bit. It says list the possible rational zeros, then use the calculator to find them. Okay, we're going to find our zeros, we're going to check them using our possible rational zero test. So with the possible rational zeros, you have the factors of the last term, your constant term, over the factors of the leading coefficient. So I have the factors of the constant, which are plus or minus 2 and plus or minus 1. I don't know why I didn't put it in order. It doesn't really matter though. And factors of your first term are also plus or minus 1 and plus or minus 2. So when you list these out, 2 divided by 1 is 2. So I have plus or minus 2. Also, 2 divided by 2 is 1, so plus or minus 1. 1 divided by 1 is 1. I already have it. 1 divided by 2 is 1/2. So plus or minus 1/2. These are the only rational zeros. Notice, a square root though, if I have like the square root of 3, this is not a rational number. So this is not going to show up in our test. This is only testing for possible rational zeros, not necessarily going to give them all of us. Okay, so I went ahead and typed this in a calculator. So I have our equation in here, into your y equals. Now looking at my picture, it looks like it crosses at negative 2-ish. So second calc, I'm just going to try to find it. 0, left bound. Where's he at? Oh, he's way far down. Okay, I'm trying to move it back. Banana phone. Okay, there's left bound, right bound, and enter one more time. So that's a weird number, negative 1.13. It's nothing like what we found, but let's try to find one that we found. Second calc, let's go to another one. 0. So I'm looking for plus or minus 2, plus or minus 1, plus or minus 1/2. We already know it's not going to be negative 1 because that one was at negative 1.13 something or something like that. So this one looks like it might be negative 1/2, so I have my left bound, I have my right bound, don't care about guessing. It's pretty close, but I'm not really quite sure about that, so I'm going to say it's also not negative 1/2. Okay, I'm going to calc my 0 again, but I'm going to try to see where these guys are. We can tell that that one is not quite at negative 1, but this one might actually be 1/2. So I'm going to get to the left of it, get to the right of it, press enter one more time. Pretty close, but not quite 1/2 either. So this is kind of weird. I'm not sure why it's not working out. But none of these are going to work in this case. So this is an instance where none of them actually work because these are all coming out as like 0.51 something. Okay, that's not 1/2. 1/2 is 0.5. We also had like negative 1.13. So even though we had all of our possible rational zeros just by doing our test, none of them actually work. Sometimes they will, sometimes they won't. Find a polynomial with a given zeros. This isn't like our possible rational zero test. This is basically just finding the polynomial and working backwards. We have the zeros. Okay, this is just like the things that we did in 2.1 or 2.2. My apologies. So in order to have 1, we had to have a factor of x minus 1. In order to get a 5, we had to have a factor of x minus 5i. And in order to get a negative 5i, we had to have a factor of x plus 5i. So in order to get a polynomial with that, I can just multiply these three things together and see what the polynomial is. Okay, I will tell you though that first it is easier to multiply these two out because in the end we will get rid of the i's. So I'm just going to leave this x minus 1 right in front, and I will FOIL factor out these guys. So I'll have x squared plus 5ix minus 5ix, so that'll go away. So I'll have minus 25i squared. I know that I squared is negative 1, so this part is negative 1. Negative 1 times 25 is plus 25. So really I have x minus 1 times x squared plus 25. Since I squared is negative 1, so negative 1 times negative 25 again is 25. Then it's just a matter of multiplying these out. So distribute your x to both terms, your -1 to both terms, and in the end we'll have f of x equals x cubed minus x squared plus 25x minus 25. And there's your polynomial with the given zeros. We just worked backwards. This problems like this are a little bit more involved. So take a second, pause the video, read it, write it down, and then when you're ready, click continue. Okay, so ones like this, I know that x equals 2i. Since I have a conjugate pair, then x must also equal -2i, because don't forget, complex numbers happen in conjugate pairs. So really, I already have 2 of the zeros, and since there's only 4, I need to just find 2 more. Okay, so how in the heck am I going to do that? Well, in order to get these, this factor had to be x minus 2i, and this factor had to be x plus 2i. So kind of already I know the polynomial x minus 2i and x plus 2i, these two things are factors. So if I multiply these out, it'll be x squared, well come on, write it 2. There it is, minus 4i squared, which is the same thing as x squared plus 4, since I squared is -1. I know that this is a factor. This is one part of my polynomial times something else. I don't really know what it is, but I have my original polynomial. So here's where long division is going to come super duper in handy. If I divide this out of this, if I divide my factor out of here, then I will have my other factor. So I have 2x to the 4th minus x cubed plus 7x squared minus 4x minus 4, and I'm going to divide out x squared plus 4. Okay, so back to polynomial division. In order to get this x squared up to an x to the 4th, I need to multiply it by x squared to make the 1 into a 2. 1 times 2 is 2, so then multiply your 2x squared into both of these. Don't forget to distribute to the x squared and to the 4. So you'll have 2x to the 4th, 2x squared times 4 is plus 8x squared. And make your signs negative. Change your signs. Don't forget to subtract. So then 2x to the 4th is 0, so negative x cubed minus x squared minus 4x minus 4. So I have 2x squared. Now I need to make the x squared into an x cubed, so I know I'm going to have to multiply by x. And in order to get the 1 into a -1, I have to multiply by -x. So again, multiply, distribute the -x to both terms, so you'll have -x cubed. -x times 4 is minus 4x. Once again, change your signs, so plus and plus. So you'll be left with -x squared minus 4. And then once again, x squared plus 4. Well, the only thing that I really need to change here are the signs, because x squared is already x squared, so in order to make 1 into a -1, I just multiply by -1. Once you do that, and you change the signs, there is no remainder. So therefore, this is like my other term that I'm multiplying by in order to get back to here. So I have 2x squared minus x minus 1. And then we can try to factor that thing. So this will be x squared plus 4. Okay, we have 2 of our zeros in here. Really, I only care about these 2 zeros over here, though. 2x and I have x. I know that they have to be different signs. They multiply to be a 1, so I know it's going to be 1 and 1. Now I have to have minus there and plus there, so then I have -2x plus x will give me a minus x in the middle. Pull out your other 2 zeros from these. Since this is what f of x equals, We already got the two zeros from that one. We have something times something times something. So I don't even need to set this to 0 because we already did it, right? We have the two zeros right there. Okay, so I just need to find the other two zeros. So 2x plus 1 equals 0 and x minus 1 equals 0. So move over your 1, divided by 2, so x equals negative 1/2. There's the third one, and x equals 1. There's the fourth. We'll do more of these, don't worry too much. Last example that I'm going to look at today. We have find all the zeros of this polynomial and write it as linear factors. Don't forget linear factors just means lines. So like this is y equals mx plus b. This is a linear factor. So all we're trying to get is x by itself plus or minus some number. We don't really know what it is, but just as long as the x is to the first power, that's all we really care about. So in looking at this, I notice that this is a perfect square, that's a perfect square. So already I have a difference of squares. So in order to factor this thing, I can say this is x squared plus 9 and x squared minus 9. This one is also a difference of squares. This one is not. But if I look at just this one off to the side over here, if I try to solve for 0, if I'm looking at my factors of this thing, I know x is going to equal plus or minus 3i, since I had to take the square root of negative 9 when I moved it over to the other side. So there's my two factors right there. So f of x equals x plus 3i and x minus 3i. Okay, that's just coming from that term. And then from this term, that's a difference of squares just like our first term kind of was. We have x plus 3 this time and x minus 3. So there it is. They're all to the first power. So we have it as linear factors. Thank you guys for watching. I hope this has helped. I know this is a really confusing section, so make sure you ask a lot of good questions in class as well.